Hello, in this video, I'm going to be showing you how to graph the functions sine of x and cosine of x. So here you can see I have a unit circle that I made and filled out. It's not perfect, so I encourage you to look one up online, and if you aren't aware of what a unit circle is, then I would recommend that you watch the video that I made on that. So, to start, I'm going to graph sine of x, and on the x-axis we have theta and radians, and in y we just have the value of that, and I have it so that the graphs sine of x and cosine of x have minimum and maximum y values of 1 and -1, unless you modify it by multiplying the function by 2 or something like that. So I want to start by labeling my my x-axis, and I'm going to make this spot pi over 2, pi, 3 pi over 2, and I'm going to continue it with increments of pi over 2 up to there. Okay, so in my unit circle video, I discussed how a coordinate point made by a triangle intersecting with the unit circle, the x value is equal to cosine of x, and the y value is equal to sine of x. So we're going to be looking at where the we're going to be using the angle made by the triangle to figure out where the point where it intersects with the circle. So once we figure out where it intersects with the circle, we're going to use the coordinate point that we want to find the y value. So let's just start with 0. At 0 degrees, it's just going to be it's just sort of going to be a straight line. So that intersects with the unit circle at 1, 0, which means that the sine value of 0 is just 0, because that's the y value. And then I'm just going to go to pi over 2 first, and that's 90 degrees. It's 90 degrees right here. And that point is 0, 1. 0, 1, so I'm going to put the 1 right there. Now, let's go to pi. Oops, here. Pi. And the point where it intersects with the unit circle is -1, 0. So it's going to go back down to 0. And then, now, 3 pi over 2, or 270 degrees. And that is going to put us here at 0, -1. So now we're going to hit -1 at 3 pi over 2, which is right there. And now 2 pi actually brings us all the way back to the beginning at 1, 0. At 1, 0 right there, which means that it's going to go back to 0. And now for the last point, we're just going to put here 5 pi over 2, which is another pi over 2 counterclockwise rotation, which brings us back here to 0, 1. Sorry, that's the wrong color, but I think you get the point. It's going to be 1 now. It's going to be 1. 1 sec. That's pi over 2. Here's 1. So, just looking at this graph, it kind of looks like it has a zigzag shape. But let's just be sure, because if we test the point pi over 4, right in between, about right there, that's where pi over 4 is going to be. Oops, wrong button. pi over 4, we're going to have square root 2 over 2. But that's not going to be at exactly 1/2 like we would expect if it was just a straight line. And square root 2 is actually about right there. And if we want to check pi over 6, it is 1/2. So pi over 6, I would say it's about right there. 1/2, so like right there. And you may notice that it kind of just looks like a curve. And if you test more points along here, you'll see that it curves back down as well. And it kind of continues just continues like that as we go along the graph. There we go. And that is our graph of sine of x. It's not perfect, but you can see that it has a curve, and it goes up and down and up again, and that is called a sinusoidal curve. But basically, it's just a curve. It's like a wave, and it's actually used in physics to calculate like equations of waves and stuff. So, waves and stuff. So now let's move on to cosine of x. Let's start back down at 0 again, but this time, notice, it's not 0. We're going to start at 1. Starting at 1. And then, as we go up that way, it's 0 now. So, 0. And then, going counterclockwise once again, we're now at -1. And that's going to be right there. There's -1. And then here at 270 degrees, we have 0 again, because remember we're doing the x value, so the y value. And at 2 pi, right back to the beginning, so it'll be at 1. And then 5 pi over 2 is at 0. So we have a very similar shape to the sine graph, but it's almost as if it's been shifted to the left. So once again, if we test like the point if we test the angle pi over 4 radians, we'll actually get the same thing as we got in the sine. And our graph is going to look something like this. And it's going to go up and down. And then here's what our graph of sine of x and cosine of x looks like. It doesn't look perfect, but let's just take a second to look at the intersection points, which I'm going to mark with, let's see, is yellow a good color? Yeah, we'll mark them with yellow. So I mentioned this when we were doing the cosine graph, that this point is pi over 4, comma, square root of 2 over 2. And now we come over here, we see this right here. This is, it is, what is it? It's 5 pi over 4. So this is going to be 5 pi over 4. But let's see what the y value is. 5 pi over 4 is right here. And the y value of that, the value of that is actually very similar. It's just the negative version of it. And this makes sense because the two values are the same, the two coordinates, and that means that sine of theta is equal to cosine of theta, which is what we need for that. And then when we come back up here at 9 pi over 4, we're going to have square root of 2 over 2 again. So this is our graph of sine of theta and cosine of theta. I'd like to thank you for watching, and if you have any questions, leave them in the comments, and I will try to answer them. So I hope you learned something from that. Thank you.